I'm going to do the quotient identities. Okay? You don't have to be able to reproduce the proofs for them. Okay? But you should be able to follow me. Camera shot at, yes. Okay? So I'm going to prove 3 identities to you, and all you should be able to do is follow me. Now, in the past, I've had students who have chosen to remember how they were developed, because that's how they remembered them. Okay? So we're going to start off with a reference diagram. Using this diagram, I'm going to write what cos and sine are. So what would the ratio for cos be?
Y over X?
Nope. Nope.
It's like
X. A over hypotenuse. Sine? Okay, does that make sense? Okay, so what I'm going to then do is I'm going to divide sine by cos, and I'll be able to manipulate these and see what happens. So sine divided by cos is y over r divided by x over r. What do you do when you're dividing fractions? Okay, the second one. And what operation do I now use? Is there anything I can do here?
Get rid of the R's.
What is y over x?
Tan.
Okay. Opposite over adjacent. Okay. Meanwhile, let's do cos over sine. So what 2 things would I divide this time?
X over R divided by. Oh, sorry, wow.
And what's going to happen now?
You just put X over R times R over Y.
What happens? What's x over y?
Isn't that cotangent?
Okay, so far we've got 3 identities that you knew before today. I've just developed 2 new identities for you. Should I stay in this zone? Or can I go to that spot?
I don't know. I would have to move the iPad.
Okay, I'll stay here. So now I'm going to do the Pythagorean identities, whatever I say it. Pythagorean. God, it's got to be that thing. Really messing me up. At least I spelled identities correctly. So again, I'm gonna use this diagram as reference. I'm gonna write these, or use these again, and I think I'll add tan to the mix, just in case I need it. What relationship can I say about this triangle?
Using that triangle again.
Yep. Using that triangle, what can I say? Okay, so, all right.
A squared plus B squared equals C squared.
Okay, can you up the ante with those letters? There's three of them, that's why I put it on one here. Three examples. Huh? There's three identities. All right, so what I'm gonna do with this is I'm gonna divide this whole question by, how about r squared? I'm allowed to divide an equation by something as long as I do it to all terms, or left side and right side. Is this okay to say that?
Yes.
So therefore, what about the last one?
Equals 0.
Nope.
Maybe 1.
Right.
Referencing my sine, cos, and tan, what is x over r?
Cos.
Notice the way I'm writing cos squared. And y over r? Okay, if you look on your identity sheet, you'll notice that it's usually the sign that's written first, but it doesn't matter. Just created another identity for you. So this means that if you were to pick a value for theta, 302, you signed it and squared it, and then did the same thing with cos, it would total 1 every single time.
Why did you, what did you find?
Why did I flip?
Like, why did you put the sign in front? And-
Just because it's consistent with your sheet.
Oh,
But cos squared plus sine squared is the same thing as sine squared plus cos
Yeah.
squared. Okay?
okay.
So either version doesn't do the same. Waiting. Start over again. This time, how about I divide by x squared? So what do I get at the front this time?